Nice to meet you. I'm Khatar Choktai and you're watching my YouTube channel School of Advanced Chemistry. I'm going to explain alkenes for O-level chemistry students. Let's get started. In this topic, I'm going to explain alkenes. What are the alkenes basically? How alkenes and hydrogens are supposed to be formed as a result of cracking. What are the basic reason of cracking or reason for the cracking of large molecules? The fourth one, I'm going to explain the test to distinguish alkene and alkene. How can you distinguish between alkane and alkene are saturated and unsaturated hydrocarbon by a simple reaction with bromine, aqueous bromine. Then I will explain, state the addition reaction only gives the one product. I mean, what are the addition reactions? State an addition reaction. I mean, what are the addition reaction? Those give only one product are called addition reaction. And the sixth and the last point is basically the chemical properties of alkene. What are the basic chemical properties of alkene and so on. Let's get started and I'm going to explain these properties turn by turn. Let's get started. Alkene. Number one, hydrocarbon. A hydrocarbon that is having carbon-carbon double bond, at least one. So there are two portions of the definition. What do you mean by the term alkene, or what are alkene basically? Hydrocarbons, I mean elements, compounds having only two elements. Compounds having two elements are called hydrocarbons. So hydrocarbons, those are having at least one carbon to carbon double bond. If there is a hydrocarbon and it is having at least one carbon to carbon double bond, then this compound is generally said to be or known as alkene. I mean, it will belong to alkene homologous series. So alkenes are the hydrocarbon and those are having carbon-carbon double bond in it. At least one carbon-carbon double bond in it. They are said to be alkenes. They are called alkene. For example, the first one, the smallest one, alkene is C2H4 and this is said to be ethene. Smallest alkene is ethene. I mean the homologous series of alkene is starting from ethene. The first member is ethene. The second member is C3H6 that is said to be propene, and third member is having 4 carbon atom that is having C4H8 said to be butene, and the fourth member is having 5 carbon atom, it is having 10 hydrogen atom and it is said to be pentene. So ethene, propene, butene, pentene, these are the successive members of homologous series of alkene. Alkene family start from ethene, then propene, then butene, then pentene, and so on. The general formula, you can see it over here, you can check it, you can develop through this sequence, through this series, that is CnH2n. This is the general formula of alkene. So alkenes are having carbon and hydrogens. Number 2, the ratio of carbon and hydrogen is equal to 1:2, CnH2n. So the hydrogens are double as compared to the number of carbon atom. So general formula is CnH2n and the first member is going to have at least 2 carbon because there must be carbon-carbon double bond. So the first member is ethene having 2 carbon atoms, propene 3 carbon atoms, butene 4 carbon atoms, and pentene 5 carbon atoms. As you know, if the carbon is equal to 2, its name will start from eth. If any compound that is having 2 carbon atom, its name will start from eth. If any compound that is having 3 carbon atom, any compound, I mean it may be hydrocarbon, it may not be the hydrocarbon, it may be a derivative of hydrocarbon, its name will start from prop. Its name will start from prop. If any compound that is having 4 carbon atom, its name will start from but. Its name will start from but. Any compound that is having 5 carbon atom in it, its name will be written as or can be written as or may have pent. And the last word, these are called suffix. These last word are "-ene". "-ene" is the indication of presence of carbon-carbon double bond. If any compound that is having a double bond, 1, 2, 3, or more than 3 double bonds, then the ending name will be "-ene". I mean, it may be simple "-ene", it may be diene, and so on. So this is the homologous series of AlkENE. Hydrocarbons having at least one carbon-carbon double bond in it are said to be or known as AlkENE. Now come to the next one. How alkenes are formed, how alkenes are made basically. The process is said to be cracking. Cracking is of two types. It may be cracking may via heat, that is said to be pyrolysis, or cracking generally said to be catalytic cracking. That may be in the presence of catalyst. So cracking may be in the presence of heat, cracking may be in the presence of catalyst. That is the two basic kind of the cracking. So what is the cracking basically? Cracking is the breakdown of large molecule into small molecules, and one of the molecule must be an alkene. Breakdown of large molecule, usually alkanes, and into small molecules are going to be formed, and usually one molecule that is being formed is alkene. For example, I'm going to break this smallest molecule, smallest alkane. On cracking this ethane, it is called ethane. The smallest, second smallest alkane, 2 carbon alkane I mean, and this can be cracked, and the cracking is going to have number 1 hydrogen, number 2 ethene, hydrogen and ethene. So whenever you are going to perform cracking via heat or via heat and catalyst, I mean catalytic cracking, whatsoever is the condition of cracking, the result will be one alkene plus hydrogen, or there may be an alkane. I'm going to crack butane, for example. This is butane, 4 carbon atoms are over here, 10 hydrogens are over here, C4H10. So this is an alkane, butane. On cracking butane, let's suppose only 2 fragments are going to be formed over here. So in this case, let's suppose I'm breaking this molecule from here, and there will be, number 1, there will be methane that is having only 1 carbon atom, that will be alkane because it cannot have carbon-carbon double bond as it's a single carbon molecule. And the next one that is having 3 carbon atom, the next portion, the other portion, it will be an alkene. So these two are the basic fragments, small molecule outcomes of cracking. Whenever you crack a large molecule or any molecule, then there is the formation of at least two molecules, 2 parts, and one is having alkene, the second one is having carbon-carbon double bond, that is said to be alkene. Why cracking is carried out? What is the reason behind it? The reason is basically these newly born fraction are having low melting point, low boiling point, and they are highly flammable. They can be combust easily. So they are in more demand, more flammable and more demand. They are more flammable, so they are more in demand. Right. So that is the basic reason of cracking. So to meet the demand of these small molecules, large molecules are cracked into small molecules. Now come to the next one. What are the addition reaction? Addition reaction are the reaction in which 2 species are added up. For example, hydrogen, when it is allowed to react with carbon-carbon double bond, let's suppose ethene, in the presence of nickel and heat. Nickel is behaving as a catalyst in this case, and I'm going to heat it at around about 300 degrees Celsius. So there is a formation of basically one compound that is called ethane, single product. Usually, single product is formed. Usually, in most of the cases, single product is formed. So when two species are added up to make a single compound, to make a one type of compound or one type of molecule, then this reaction is said to be addition reaction. And addition reaction is the basic property of all type of alkenes. All alkenes gives addition reaction exclusively. So basically alkene can give two reactions, two type of reaction you can say. As far as the O-level syllabus is concerned, you will have to memorize or you will have to revise two basic properties. Alkenes can give combustion. Can give combustion. Combustion is basically a sort of oxidation. Reaction of a hydrocarbon or derivative of hydrocarbon or any organic compound with oxygen at high temperature is said to be oxidation. Is known as oxidation, is also said to be combustion. So combustion, that is in fact oxidation, that is called complete combustion. Especially I'm going to talk about the complete combustions. And when alkenes, alcohols, acid, when organic compounds are allowed to react with oxygen at high temperature, they form their elements, make new compounds. New compounds are basically oxides, carbon dioxide, hydrogen oxide, and so on. So this reaction is said to be combustion. All alkenes can be combust. They can react with oxygen to make CO2 and H2O, hydrogen oxide, as a product of complete combustion. The next property of alkene is basically addition reactions. Next property is addition reaction. Addition reactions in your syllabus, alkenes can give addition reaction with hydrogen. Alkenes give addition reaction with halogens like aqueous bromine. Alkenes give addition reaction with water HOH, with steam or water at high temperature. So we can add hydrogen into alkene, any alkene, ethene, propene, butene, pentene, and so on. We can add bromine, aqueous bromine, halogen at room temperature into any alkene. Ethene, propene, butene, and so on. We can add water in form of steam. That is steam at when it is heated. When we heat the water, it becomes steam. So you can add steam into the ethene. At high temperature, this addition reaction gives the alcohol. So basically, in our syllabus, we will discuss these three addition chemical properties, addition reaction of alkene. The fourth one chemical property is called combustion. So alkenes can be combust, and on complete combustion, all alkenes will give CO2, carbon dioxide, and H2O, water molecule. On addition of hydrogen, there will be formation of alkene. On addition of bromine, there will be the formation of basically bromoalkane. And on addition of water, there is the formation of alcohol. So alkene can be changed into alkane. Alkene can be changed into haloalkane, halogen and alkane. And alkenes can be changed into alcohol by reaction with steam. So these three reactions are said to be addition reaction. Once again, what are the addition reaction? Addition reaction are the reaction in which we can add two species to make single. Usually we make single product, so that reaction is said to be addition reaction. First of all, I'm going to explain combustion once again, then I will explain this addition reaction. There is another addition reaction that is said to be the mutual addition of alkene. That is called polymerization. Addition polymerization. We will discuss this addition polymerization in next topic, but overall, alkene can give combustion reactions, oxidation at high temperature. Alkenes give addition of hydrogen, alkene give addition of bromine, alkene give addition of water or steam, and so on. So these are the basic major properties of alkene. I'm going to explain number one, combustion of alkene. For example, I'm having ethene, C2H4. 1 to 2 ratio is the ratio of carbon and hydrogen. Now I'm going to react it with oxygen at high temperature. In excess oxygen, I'm going to burn this ethene in plentiful supply of oxygen. So there will be 2 mole of carbon dioxide as 2 mole of carbon. So 2 mole of CO2 will be formed. Plus there will be 2 mole of H2O, that will be steam. At high temperature it will be steam and it's a gas. So CO2 and H2O, 2 gaseous products, are formed as a combustion of any alkene. And for the sake of balancing, I'm going to balance this equation basically. And here is 3O2. So 1 mole of ethene is going to demand 3 mole of oxygen. There is formation of 2 mole of CO2 and 2 mole of water. Now come towards the next property, that is addition of hydrogen. If I'm having this ethene once again, and I'm going to add hydrogen, H bond H, this is hydrogen in the presence of nickel and 300 degrees Celsius. These are said to be the conditions. Under such conditions, one of the double bond is broken down. One of the CC bond is broken down. Here is the breakage of HH bond, and one H will be to one carbon atom. Other H will be to the other carbon atom. So finally, we are going to have alkene. We have made a single compound that is said to be ethene. Initially it was ethene. Now it is ethane. It's ethane. Same reaction is carried out when we change oil. Oil is reacted with hydrogen to make solid product that is called margarine. So margarine is formed, that is a solid basically. So when you are going to make solid compound from oil, and when oil is solidified into ghee, into margarine, then this reaction is again said to be addition reaction. And in this reaction, we add hydrogen in the presence of nickel as a catalyst, and we heat the whole the mixture. We heat this whole compound in absence of oxygen, and the heating is basically carried out above or at least at 300 degrees Celsius. So that is the addition of hydrogen. So upon addition of hydrogen, ethene can be changed into ethane. Alkene can be changed into alkane. That is the shortest way, simple way to convert alkene into alkane. That is called addition of hydrogen. The next one is the test for unsaturation. Test for unsaturation. If you want to distinguish between saturated or unsaturated hydrocarbons, then there is a test. We add Br to aqueous. Aqueous bromine is added into the sample. If the sample is having carbon-carbon double bond, then it reacts with the sample at dark conditions. If there is no light, no sunlight, there is no heat at RTP, room temperature and pressure, and you are using the dark conditions, so Br2, aqueous bromine react with alkene. Once again, there is a breakage of one of the carbon-carbon bond, double bond, and there is the addition of 2 bromine. So Br bond is broken down. CC1 of the CC bond is also broken down, and there is an addition of Br on each carbon atom. And you know what is the color of this aqueous bromine? It is reddish brown. It is reddish brown initially. Finally, it's going to have dibromoethane. Its name is dibromoethane, and it's alkane, and it is colorless. It is colorless. So if any compound, if any hydrocarbon, especially hydrocarbon, or it may not be the hydrocarbon, if any compound, if it is going to decolorize Br2, if it is going to decolorize Br2, bromine, aqueous bromine, then it will said to be unsaturated hydrocarbon. But this reaction must be carried out in dark, not in the presence of sunlight. It must be carried out at room temperature. If any compound, if it is decolorizing aqueous bromine in dark, at room temperature, in absence of sunlight, UV light, then it will be known as an unsaturated compound, or an unsaturated hydrocarbon, or an unsaturated derivative of hydrocarbon. So this is the basic test for unsaturation. If any compound that is incapable to react with the aqueous bromine, if it is not decolorizing the aqueous bromine in dark, so it means it's not having any carbon-carbon double bond. It's not having any carbon-carbon double bond. So this is the basic test to differentiate between saturated and unsaturated. Unsaturated mean if they are having carbon-carbon double bond, at least one carbon-carbon double bond. So this is the simplest case, this is simplest test to distinguish between saturated and unsaturated, between alkenes and alkanes, and so on. Now come towards the next one. There is the addition of water. Addition of water, H2O. We can add water, in form of steam at high temperature. Again, I'm going to start from carbon-carbon double bond, and I'm going to add HOH, and the conditions are H3PO4, that is acting as a catalyst, and 70 atm pressure, and 300 or more than 300 degrees Celsius temperature should be there. So once again, there is a cleavage of one carbon-carbon bond. There is the cleavage of HOH bond. One carbon is going to have H, other one carbon is going to have OH, and in this case, we are going to have an alcohol, and that is said to be 2-carbon alcohol, 2 carbon, 1 OH group, other are all hydrogen, then it is said to be ethanol. It is said to be ethanol. So whenever any alkene is allowed to react with H2O at high temperature, at 300 degrees Celsius, this H2O is in form of gas. It is said to be steam. When it is allowed to react with steam, then it reacts with the steam and it's going to make alcohol. It will make alcohol, specifically in this case ethanol, otherwise alkene plus H2O goes to alcohol. So this alcohol sometime this alcohol may be of more than one type. For example, I'm going to start from propene. This is propene. And if I'm going to add water into it, HOH, you can write water HOH in organic chemistry especially. So if I'm going to break this carbon-carbon double bond, first step is to mark double bond carbon. Let's suppose this is carbon A and this is the carbon B. So these two carbon are having carbon-carbon double bond, and these two carbon, one is said to be A and other one is said to be B. So whenever there is a carbon-carbon double bond and you are going to break it, then there is also, the breakage of H and OH bond. Basically, this alkene is said to be unsymmetrical alkene. This is called unsymmetrical alkene. And this water molecule is also unsymmetrical. reagent, unsymmetrical reagent. If the both are unsymmetrical, how can you check the unsymmetry or symmetry of the molecule? I'm going to cut this alkene from carbon-carbon double bond. So there are two different portions. One portion is having one carbon, other portion is having basically two carbons. So alkene, if the alkene is supposed to cut from carbon-carbon double bond and it is having two different parts, it is said to be unsymmetrical alkene. Same is the case, this HOH, if it is cut from a single bond, any single bond, here are two single bond, HO single bond H. So if these both compound are unsymmetrical compound, then there will be two products. There will be two products. There will be two alcohol in this case. How can we made two type of alcohol? Let's see over here. For example, I'm going to write the basic portion over here, that is propene. I'm not writing the double bond this time. I'm just writing the simple all single bond and all hydrogen atom. Now you know it's carbon A and it's carbon B. I'm attaching hydrogen with the carbon A, simple hydrogen, and OH group I'm going to attach it with carbon B. So this is the one alcohol, one product, one type of alcohol is this one. What is the name of this alcohol? This alcohol, the name of this alcohol is basically propane-2-ol. Its name is propane-2-ol. What is the second possible compound product? Once again, I'm going to write simple 3 carbons with no double bond. You know, this is carbon A, this is carbon B, and I'm going to write, now this time, I'm going to attach OH group with this carbon and H group with this carbon. So I have made a new alcohol. This is a new possibility of the product. So this compound is said to be as it is having 3 carbon atoms in carbon-carbon single bond -1-ol, as OH group is present at carbon number 1. So it is said to be propane-1-ol. In this case, OH group is present at carbon number 2. So it is said to be propane-2-ol. So these are two different alcohols. One is said to be propane-2-ol, other one is said to be propane-1-ol. So these are not the same compound. So sometime only in case of, especially in your syllabus, in case of water. If you are going to add water, then you will check the symmetry of the molecule. Water is obviously unsymmetrical. You will have to check alkene. If the alkene is unsymmetrical, then it will make two alcohols, not single. It will make two alcohols. One will be, having the different name from the other. And one will be, in this case, propane-2-ol, and other will be propane-1-ol. So two isomers will be formed, and isomers are supposed to be different compounds, different products, different compounds, and so on. So these are the basic reactions, basic chemical properties of alkene: combustion reaction of alkene, reaction of alkene with hydrogen to make margarine. If you are going to add into oil and hydrogen mixture is going to give you the margarine, solid compound. If you're going to add halogen, especially bromine, then you are going to have haloalkane, bromoalkane, in this case dibromoalkane. And if you are going to add H2O, steam, then there may be more than one compound. There may be more than one possible alcohol. And how to check the possibilities? Here it is. So you will check the symmetry, the symmetric nature of alkenes. Either it is symmetric or unsymmetric, then it will let you know about the nature of the alcohol that is being formed at the moment. So these are the general properties, general chemical properties of all alkene. I'm not going to discuss polymerization. I'm not going to discuss the physical properties. Alkenes are non-polar compounds. Alkenes are insoluble in water. Alkenes are not going to react with acid, with alkali, with metals, and so on. The next thing is these alkenes, especially these first three member of alkenes are gases at room temperature. From carbon number 5, that is the fourth member of alkene homologous series, it's a liquid, right? So they are the general few physical properties. So general properties are the few physical properties, and the chemical properties are basically two type of chemical properties are over here. One is said to be combustion, that is reaction with oxygen, and other one is said to be addition. So these are overall general main points about alkene. So that's all about this crash course. Please hit the bell icon, thumbs up, and subscribe if you are not yet subscribed, and share it with your friends. Thank you very much. Have a nice day.